And let's correct it. Write this down if you're not sure how to answer these properly, because I kind of gave you a hint. Should happen, actually happened, but that's not the definition. That's not describing it accurately. Experimental probability, the likelihood of something happening based on actual trials or experiments. I'm just going to go actual trials, right? Um, that's basically in a nutshell what you can write down there, right? Theoretical probability, some of you say it's based on theory, right? And I think I know what you're trying to say, but it's not quite what I'm looking for, right? Theoretical is the likelihood of something happening here's important, based on what? Total possible outcomes. Based on total possible outcomes. Example, I'll give you some examples, like a die, that'd be 6, right? A coin, there'd be 2, right? Cards, there'd be 52, right? So it's based on what are the possible outcomes that are out there. Right? So it's not based on actual you drawing cards. It's based on, hey, let's look at how many possible outcomes are there. And that's theoretical. So I hope that makes sense. Next, John rolled a standard 4-sided die. That's important right there. Like that actually tells you that in theory there are 4 options, right? 1,800 times recorded the following results. Okay, so we know that in theory this technically adds up to 800. If I didn't tell you that, you just add it up, right? State the experimental probability of rolling a 2. Experimental. So you're going to base it on this. There's a 2. So you're going to say 395. It's probability. Okay. So 395 over 1800. That's all. We're going to leave it like that. I would say don't reduce. Don't give me the decimal, because if you do and it's not rounded correctly, I need to take half a mark off. So unless I ask for it, just leave it like that. Okay. Theoretical probability of rolling a 2, well, it's 1 out of 4. Like there's just 4 options. So I want them side by side like this. Sometimes it's nice, right? This is 0.25. This would be 395 divided by 1800. This is 0.2194, right? This is 0.2194. So they're not the same, right? And that's like it should be, but it's not in this case. State the experimental probability of rolling a 4, right? The 4, there's 535 events that happened where a 4 was rolled out of the 1,800 total trials that were performed. And this is still 1 out of 4, theoretical probability. State the experimental probability of rolling an odd number. Just a hint, odd and even, there's always the same amount when you're starting from 1 to whatever. I could go from 1 to 100. 50 numbers would be odd, 50 would be even, right? Remember that. So experimental of rolling odd. So odds would be the 1 and the 3. So you have to add these up. So 410 plus 460 over 1,800. And that's what? 870. I know my math. It's just Monday. 1,800. There we go. State the theoretical probability of rolling an odd number. 2 out of 4, which is half, right? Okay. State the experimental probability of not rolling a 3. Uh-oh. Mr. Dirksen with his knots, right? So what you do here is, I would recommend take 1,800. You don't want 3, right? So you're going to take away the 460. take it away. And what's going to go underneath? Not the 460, 1800 is always the total, right? You cannot have a number bigger in the denominator. Like if you have something bigger, if you have something bigger on top than bottom, then you're in trouble, right? Because it's over 100%. So what are we at there? 1340 over 1800. Let's leave it like that. You can trim the zeros, but it's okay. State the theoretical probability of not rolling a 3. 3 out of 4, right? Like you can go 4 minus 1 over 4, which is 3 out of 4. And what could you do to bring the experimental probability results closer to the theoretical probability? Explain. John should increase the number of rolls. Okay, so one thing that you should probably be like, Mr. Dirksen, I think 1800 rolls is quite enough. So you have a bit of a point there. You have a bit of a point, but still, if you increase it, you would definitely get them closer together. And we're always assuming that this is a die that is perfectly even, like there's no defects on it, it's completely random, all of those things, right? All of those things. Okay. Next page. Zach, you missed a very good speech on cell phones and such. Too bad. I forgot that you had left, but that's okay. I'll fill you in later. Celia is spinning a wheel depicted. She spins it 30 times, recorded the following results. So this is supposed to add up to 30. Okay. Answer all in as a fraction and decimal. Okay, so we'll do that. State the probability of the spinner landing on purple. We're going to go theoretical. And I made a really bad spinner here, right? But how many purples do we have? I'm going to go off my key here. Otherwise, it's going to take too long. 1, right? There's 1 purple. So it's 1 out of 16. This has 16 sections, right? I will never, unless I ask you, find the mistake on the spinner, like find what's wrong with the spinner. Don't worry about some sections being bigger than others. But that technically they should all be the same. But I'm doing this by hand, so I can't always draw it perfectly. Experimental, I go over here, and it's 3 out of, this is what? 0.0625. And experimental is 3 out of 30, which is 0.1, right? That's for purple. Probability of the spinner landing on green. So theoretical, I know that's going to be out of 16, right? Because there's 16 sections. How many greens do I have? I counted 3. Is that right? That is 0.1875. And the experimental is actually easier. You just go here. There's 9 out of 30, which is 0.3. Okay. And then I told you to change this to odds. State the odds of the spinner landing on purple. I'm going to use my answer here. Pay close attention because this was a common mistake. In theory, right, 1 lands on purple, and on the other side, it's not 16. Yeah, you take away the number you put down, right? So this is 1 to 15. That is the right answer. So even if you're off by just 1, it would be a big deal. Okay. Experimental, I'm going to base it on this. It's 3 to 30 minus 3. So it's 3 to 27. And some of you are saying, oh, yeah, I made that mistake on the quiz, right? You'll see in a bit. We're good. Then the probability of landing on yellow. In theory, I know it's going to be out of 16. How many yellow sections were there? 4, right? Which is a quarter. Experimental, I go up on the chart, and it landed on yellow 7 times out of the 30 spins that were performed on this experiment, which is 0.2333, right? They're pretty close, pretty close. State the probability of the spinner not landing on yellow. So watch this. I'm going to go 16 sections. 3 of them are yellow over 16. So this is 13 out of 16. And that is 0.75. Am I off here? It's supposed to be what? 4 yellow. Oh yeah. Yeah. 4. So I was looking here, sorry. Yeah. This is 12, right? Because I was thinking 13 over 16 is not 0.75. No. Right, there we go. That's better. And the experimental of not landing on yellow. So we would go not landing on yellow. So we want, this is going to be out of 30. And on top, we're going to go 30 minus the 7 yellow, which is 23 out of 30, which is 0.7667. So the probability of the spinner not landing on purple. So this is 16. There's one purple, right? One purple section. That's 15 out of 16. That's 0.9375. Experimental, I know I'm going to be out of 30. 30 minus how many purples in the experiment? We have 3. So this is 27 out of 30, which is 0.9. The probability of it landing on blue, we're getting tired of this, right? But there's 3 blue sections, which is 0.1875. And then we have 5 over 30, which is 0.1667. Okay, the last question here. Lisa rolled a 6-sided die 25 times, so 6 options, but rolled it 25 times. Rolled a 3 on 8 occasions. State the theoretical experimental probability of rolling a 3. So experimental probability of rolling a 3, you rolled it 25 times, it landed on a 3 on 8 occasions, right? The theoretical probability would just be 1 out of 6. Side by side right there. Okay? All right. Whew. I'm tired of talking and I haven't even done much. Let's go to expected value. Okay? So I'm going to stop this here.